I said in today's lecture, we want to look at the production of red blood cells, also known as erythropoiesis. So we are going into something more serious and more deeper, erythropoiesis. But before we dive into production of red blood cell, we really need to first understand before we dive into production of red blood cells proper, we really need to understand what hematopoiesis is all about. Hematopoiesis is also known as hematopoiesis. Some authorities call hematopoiesis. So what is hematopoiesis or homopoiesis? Please write. Homopoiesis is defined, or it refers. Homopoiesis is defined, or it refers to the production, the growth and maturation of blood cells. Homopoiesis or hematopoiesis refers to the production, the growth, and the maturation of blood cells. The site for hematopoiesis is the bone marrow. So after birth, homopoiesis takes place in the bone marrows. But fetal hematopoiesis occurs in the liver and the spleen. So in fetus, the site of production of blood cells is the liver and the spleen. However, this site of production moves to the bone marrow, especially during adulthood. Okay? All right. The slide shows you the general outline of hematopoiesis. The general outline of hematopoiesis. In the bone marrows, or we can call that stages of hematopoiesis. Hematopoiesis begins in the bone marrow. Are we writing? Okay. Hematopoiesis begins in the bone marrow with the differentiation of uncommitted pluripotent stem cell to committed pluripotent stem cell. Differentiation of uncommitted, or you can call that inactive pluripotent stem cell to active pluripotent stem cell. I said hematopoiesis begins in the bone marrow by the differentiation. The differentiation of inactive pluripotent stem cell to active pluripotent stem cell. Is that taken? All right. The committed or active pluripotent stem cell differentiates into two kinds of cells. The first one is a lymphoid stem cell, and the second one is a colony-forming blastocyte. I said an active or committed pluripotent stem cell differentiates into two kinds of cell. Number A is the lymphoid stem cell, and number B is the colony-forming blastocyte. Is anyone lost?
Yes.
Where are you lost? Yes? We have just started blood physiology proper. So if you know this, you are good to go. I said that the active or committed pluripotent stem cell is on the slide. The committed pluripotent stem cell differentiates into two kinds of cell. The first one is the lymphoid stem cell, and the second one is the colony-forming blastocyte. Second one is the colony-forming blastocyte. Let's begin with the first one, lymphoid stem cell. The lymphoid stem cell differentiates into lymphocytes. All right? Lymphoid stem cell differentiates into lymphocytes. L for lymphocytes. This L simply stands for lymphocyte. Okay? So the lymphoid stem cell will eventually differentiate into lymphocytes. And then the colony-forming blastocytes. Colony-forming blastocytes will differentiate into three kinds of cells. The colony-forming blastocytes differentiates into three kinds of cells. Number A is the colony-forming unit erythroid. That is colony-forming unit erythroid. The E here stands for erythroid. I repeat, the colony-forming blastocytes differentiates into three kinds of cells. Number A is the colony-forming unit erythroid. Number B is the colony-forming unit for granulocytes and monocytes, GM. I said number B is the colony-forming unit for granulocytes and monocyte. GM simply means the G stands for granulocyte. M stands for what? Monocyte. Okay, and then number C is the colony forming unit megakaryocyte. Colony forming unit megakaryocyte. Or you can call that megakaryoblast. It's on the board. Look at it. If you look below, you can. I know your problem is spelling. Spelling. Megakaryocyte is on the board. Okay? I take it again. The committed or active pluripotent stem cell differentiates into two types. Number one is a lymphoid stem cell, and number two is colony forming blastocyte. This lymphoid stem cell will differentiate to form lymphocytes, while the colony forming blastocyte differentiates into three kinds of cell. Number A is a colony forming unit erythroid. Number B is a colony forming unit for granulocytes and monocytes. And then number C is a colony forming unit megakaryocyte. Good. The colony forming units for erythroid further grows and differentiates into erythrocytes or red blood cell. RO stands for red blood cell. So this colony forming unit erythroid will grow and develop to form erythrocytes or red blood cell. While the colony forming units for granulocytes and monocytes will differentiate into two sub-cells. The colony forming units for granulocytes and monocytes will differentiate into two sub-cells. I is granulocyte. Alright? And then I said I is granulocyte. And then I is what? Monocyte. So these colony forming units, GM, Gateman, will differentiate into two subcells. I is for granulocyte and I monocyte. Is that thinking? Good. The granulocytes further differentiates into three kinds of cell. These granulocytes will further differentiate. The granulocyte. What is happening? What's going on? Okay. The granulocytes will differentiate into three kinds, or simply put, there are three types of granulocytes. Okay? So let's call this AI, which means neutrophil. Neutrophils. So the granulocytes has three main kinds or types. The first one is neutrophil. The second one is, so we call this AII. The second one is what? Basophils. And then the third one, AIII, is what? Is what? Eosinophils. Okay? E for eosinophils. Yes. Yes. You want me to spell it? Okay. Is anyone lost? Who is lost? Eosinophils. It is spelled EOSINO. Then PHIIL. All right. Good. Any other question? Is anyone lost, confused? All right, going forward. Now the last cell here is a colony-forming unit, megakaryocyte. In fact, this cell differentiates into megakaryocyte proper. Okay, and this megakaryocyte will further differentiate to form platelets or thrombocytes. The megakaryocyte will further differentiate to form platelets. Any question? Further questions? Is anyone lost? Okay. Let's proceed. Today you will learn blood physiology till 6 p.m. Alright. The slide here shows you a detailed production of blood cells. Okay? We have already discussed that. Alright? So the pluripotent hematopoietic stem cell differentiates to form colony-forming unit blastocyte and then the lymphoid stem cell. This one goes directly to form lymphoblast and then which turns or differentiates to form lymphocytes. Alright? And then this one forms colony-forming unit erythroid, which differentiates to form red blood cell. And then the colony-forming unit megakaryocyte, which differentiates to form megakaryocyte and what? Platelets. Okay? Good. Then the colony-forming units for granulocytes and monocytes differentiates to form, this is colony-forming unit granulocyte, it differentiates to form myeloblasts, and then you have myelocytes, which then differentiates to form neutrophil, eosinophil, and basophil. Okay? All of these leads to neutrophils, eosinophils, and basophil. And then this one is monoblast, a colony forming unit. After that. Okay. Sorry, just excuse me for a moment. Okay. I hope you have finished studying this, so you have mastered this. Okay. If you like replaying, you need to go and learn the process of hematopoiesis. You cannot be answering doctor, making noise, telling all your village people that you are studying medicine and you don't know the process of hematopoiesis. What if you travel to the village and your grandmother asks you, your grandmother asks you, how are blood cells formed in the human body? What will you say? Your grandma does not know that one. It will shock you. It will shock you. Alright, going forward. I was going to have another class today. Okay. So erythropoiesis, subheading please. Erythropoiesis. Refers to the production. Erythropoiesis refers to the production, growth, development, and maturation of red blood cells. Erythropoiesis refers to the production, growth, development, and maturation of red blood cells or erythrocytes. The slide here shows you the stages of erythropoiesis. This slide tells you everything about the stages of erythropoiesis. So write it as subheading, stages of erythropoiesis. Stages of erythropoiesis. The stages of erythropoiesis or red blood cell can occur in three key phases. Number A is the size maturation or stage. Size maturation. Stages of erythropoiesis occur in three different phases or three main phases. Number A, size maturation. Number B, nucleus maturation. Number B is the nucleus maturation. And number C is cytoplasmic maturation. Is that again? I said erythropoiesis occur through 3 key stages: size maturation, nucleus maturation, and what? Cytoplasmic maturation. Now, as red blood cell grows and develops to maturity, the size of the cell decreases. Okay, so if you look at this diagram on the slide, you will notice that the size of these initial cells are large. Alright? But as it grows and develops to maturation, there is a decrease in the size of erythrocyte or red blood cell. Not only the size, there is also changes in the nucleus. Remember that red blood cells are non-nucleated formed elements of the blood, which means they don't have nucleus. A mature red blood cell lacks nucleus. So, but during the stages of production through growth and maturation of red blood cell, the initial stage of red blood cell contains nucleus. Alright? So, but as the cell develop and grow to maturity, nucleus is lost. The size of the nucleus decreases and eventually disappears. And then the mature red blood cell will come out having no nucleus. And then the next thing you want to observe is cytoplasmic changes. Alright? So, cytoplasmic maturation. Initially, the cytoplasm of the red blood cells lacks hemoglobin. But as the red blood cell grows to maturity, hemoglobin appears. And then the cytoplasm stains with red dye due to the increase in the quantity of hemoglobin. Alright? I hope that is clear. Good. So what nonsense am I talking about? There is size maturation, nucleus maturation, and cytoplasmic maturation. But let's dive into the stages of erythropoiesis proper. I believe the lecturer for the next class is not around. They're around? Yes. Where are you having that class? Here. Okay. Can we meet tomorrow? Yes. Tomorrow. Alright, for time's sake, we'll continue this lecture tomorrow, beginning